Let me, okay, so there's a review I want to do before we look at the quiz. Okay, so let me bring up my screen here.
Audrey, you want back on?
Okay. Let me, I don't know if you could see this or not. Let's see. Let me share my screen. Okay, do you see College Prep Math Algebra Review? Chastity, do you see that?
I'm sorry.
Do you see College Prep Math Algebra Review
If I see it right now, yeah, I see it.
on the screen?
Yes.
Okay, because I realized when I was doing the quiz, there may be some things that you have questions on. And so I want to look first at exponent rules. Okay, so let me just share my screen here again.
You're back on. All right.
Okay, Audrey's back on.
She's back on, but I'm not seeing the
audio.
yes.
Hello, Audrey.
Do you hear Barbara talking to you?
Audrey, can you hear? Audrey?
Audrey, can you hear Miss Barbara when she's calling you?
Audrey?
Audrey, are you hearing her?
I don't think she can hear me.
No, because I'm not seeing the mic. I'm talking to her on the phone.
The last time she was on, I could hear her and she could hear me. Audrey?
Audrey, when you tap your screen, tap the screen. Audrey, when you tap the screen, do you see the mic and then the video camera? Audrey.
I see it says connecting to audio.
Okay.
Audrey, I see a name now, so maybe she.
I just put her name in.
Oh, you just, okay. It's still, she's still trying to connect to audio, so I don't think she can hear.
So you, Audrey, when you tap the screen, you're not, I don't know what's, Audrey? Audrey?
I'm sorry, we having some difficulties with Audrey.
Barbara, I'm gonna talk, I don't think she, Audrey.
Is she on mute, you think?
Is that? Audrey. I think she's gonna call it. She doesn't realize I'm still on the phone with her, so she,
oh, okay.
I'm gonna call it. Let me call her to let her know.
All right. So the review, you see the screen, right? We'll go through exponents, ratio and proportion, factoring, converting words to math, and work problems. So we'll go over these and make sure you ask questions if I say something you need more clarification on it, okay? All right, so let's just first look at the exponent rules. Yannick, can you hear me?
Yes, teacher.
Okay. I may have to send you this because you can't see, you're only hearing, right?
Yes.
Okay. Well, I can email you the session, but some of these I may have to post or mail you. Okay, so let me go back up here. New share. And let's go to exponent rules. Does everybody see exponent rules and practice? Chastity, do you see that?
My keypad.
Oh, you have your Can you see exponent rules in practice?
No, it's only my keypad actually.
So you can see what's on the screen.
What's going on the lesson? No.
Oh, you can't see the screen, my screen.
No.
Okay. So you're not on an iPad, you just on the phone.
On the phone.
Oh, okay. I don't understand why you don't see the screen on your phone. You have an iPhone, right?
My phone?
You have an iPhone.
It's a smartphone, let's see.
That's what I mean. You have the smartphone. Miss
Yeah.
Beckles showed you how to look at the screen on the phone, right?
She showed me how to get in, like to use the number, the code.
But
The
when she showed you, you couldn't see something on the screen on your phone.
no.
Miss Beckles,
Already on
why couldn't
YouTube.
Yannick see? No, I don't mean YouTube. Why couldn't Yannick see what we see on the phone, Miss Beckles? You're on mute. Miss Beckles, you're on mute.
So now what to do to see?
Why couldn't Yannick see on her phone what's on my screen?
Because Yannick did not join with her. She didn't join the video call. She's doing the phone call. She didn't join
Oh,
video.
she didn't have the link to join it?
She did, but she doesn't know what to do. So when she,
Oh, okay.
yeah, she doesn't.
Okay, so she didn't go in via the link, so she doesn't see the screen.
Now if I have the TV on, can I see it?
No, you'd have to have a computer. But you
But
need,
maybe
Computer.
does she have Zoom? Do you have Zoom?
she has it on her phone, right? Well, you loaded
You
Zoom
got
to
Yeah.
her
Zoom? You
phone.
downloaded Zoom on the phone?
Miss Beckles, is Zoom on Yannick's phone? Miss Beckles, you're on mute.
Hold on. Yes, it is, Barbara. Yes, I put
is.
it. It is on her phone. She
Yes.
does not know what to do. Where it's, for some reason, it's asking for the passcode and so forth. And when she gets to that point, she just, I don't know, she's not seeing us.
So, well, let me ask you this, Beckles. She doesn't get the email that you send out that has the
Yeah.
link in it?
She
No?
does. She
Okay,
does.
so
get
you would
that.
take her directly to it, to the video, and
I
it
know.
asks you, do you wanna, if you wanna, to be in the video or not? So you have to just press yes, you wanna be in the video, and it comes up. But you still go play with the settings on top. It tells you, if you wanna if you wanna see the video.
But Chastity, she gets a link on the email. You click on the link and then you join into the
Yes.
Zoom. And
Yes.
that's the part she's not doing.
Come back on.
Yeah, maybe she should check it again, because I think this is very important. I mean,
Yeah, it's
for her to
important for
look
her
at.
to see the screen because that's a big
Yes.
part of it that's missing. So Yannick, when you went to your email and it says join the session in the place you clicked on, you saw that, Yannick?
Yes, I see your picture, Miss Baba, on the side.
No,
And
I don't mean that. I mean, when you check, when the email that Miss Beckles send you, right? You
Yeah.
get an email.
I didn't receive them. I didn't open. That's why she says I don't know how to open it.
Do you go to your
You just
email?
click in it. You just click in it. It takes you directly to it.
So do you know how to go to your email, Yannick? You know how to sign on to your email?
No.
See, that's the
On your
problem.
phone,
She's
you
not
don't do
going
that?
into her email. You have an email,
Yeah,
Yannick
Nicola
Laguerre, I
just
think
16.
16 at Yahoo. So you don't know how to sign into your email.
That's right.
On the tablet?
See, that's the problem, Ms. Beckles. She doesn't sign into her email, which means she doesn't get to the link.
No,
That's
but even if you don't sign in from through your phone, if you, I mean, even you don't sign in yet through the email, when you go into Zoom and you're typing the
No,
numbers, and password, it still asks you if you want to be on the video or not.
that's true. You're absolutely
That's
right,
what I'm
Chastity. She can still see the
Yes,
screen. That's right,
yes,
even from the phone.
yes.
That's why I don't understand why she doesn't see the screen.
Maybe she don't know how to play with her phone, and it's kind of hard for her to do it.
what?
I mean, cause yeah, it does happen. I mean,
But it should say like join Zoom meeting, Carly Beckles, join Zoom.
I would rather watch the video and learn from the video, and
Yeah, if you're handicapped when you don't see the screen that I'm bringing up.
oh yes,
Yeah,
very.
that definitely handicaps you. And I can send you what I'm going over and you can go to YouTube. But while I'm doing it, I want you to be able to see it because that way you can ask questions about things that may not be clear. We've
Yeah.
got to get
Yes, I want to
Yanni.
see it. Yes, Baba, no problem. I want to see it, but I can't.
So are you at home or are you at work or where are you?
At home.
Do you have your daughter or someone that can help you with that?
No, she's nobody here.
Do you
Yeah,
wanna do you wanna
you're not,
log out and just play with it?
it doesn't
I mean,
tell me that you didn't get it. It doesn't tell me. Uh-huh.
because it doesn't. It's not hard to do it. Once you type in the numbers and the passcode, the first
You
thing
have
that
a
asks you before you
Mail,
come on the video, even if you
right,
wanna be
Gmail.
off the video,
You
the first thing that asks you is that if you want to be on the video,
again, right?
and then you press either yes or either no, and it would direct you, especially to whatever you want to do, to be without the video or on the
Or
video.
246 at
So,
gmail.com.
Yannick, did you see that when you went on your phone? What
Or do
Astrid
what?
is telling you? Did you see that,
That's wrong. So I have the wrong thing. So that's why you don't
Yannick?
get.
No.
Yannick, you didn't see that when you clicked on when you went on your phone? You didn't see that option about the video?
No, you the
Miss
one that
Janet,
you sent me
let me
before.
ask you something. Did you just dial the number like a phone number?
Yes.
I dialed the
Oh, that's the
number.
one. Okay, so that's different. She's not going in through Zoom.
They
She's
asked
going
me
through a
they
number,
asked
through a
they
phone
asked me
number.
for my they asked me for my meeting number. I put the meeting number and they asked me for the code and I dialed the code.
So do you go through
And
Zoom or do you just
they
dial the
introduced
number?
me.
But Audrey has, I'm not Audrey, Yanni. Remember I
Yeah.
went with you, we downloaded Zoom and everything on your phone.
Yes.
And we tried to get you to join on this Saturday. And you said you saw yourself once, right?
Yes, one.
You
Yes.
had to enter through the email. Remember I taught you about the Gmail, that
Yes,
there's the
ma'am.
Google box. You go into that Google box and then there's the M, the colorful M. You will
Yes,
select,
on the yeah.
right? And when you select
Yes.
that, then your mail will open up. And I should be one of the top emails because I just sent it to you today. And then you will click on that email. It should be Carlene Beckles join Zoom meeting or something. I don't know what it looks like. I can't remember now. Did you try that?
No, now I only dial the number. I don't go to my Gmail.
Yeah. And so
You want me to go to the Gmail?
that's only this phone. So if it's not like I can talk her through it on another phone while she does it on her phone. So I mean, I can explain it to you now. You can hang up and you can do it.
Okay. Hang up.
But she said
Well,
she can go into her Gmail. So why not go into Gmail and click on that message in your inbox that Ms.
The,
Beckles sent you?
yes, the Gmail don't give me what's going on now. They give me what Miss Barbara put in the past. What you mail in the past, the past session, like the week before
No,
the
no,
22nd.
follow the link. The link. You have to follow the link that Miss Beckles is gonna send you. Once you follow the link, it's gonna direct you straight to Zoom. And then when they ask you for they're not even gonna ask you for the codes because it takes you
Right,
right
you
into
go
the
in
class.
directly, yes. No, Yannick is getting YouTube confused with her email. We're not talking YouTube now, Yannick. We're talking strictly your
About
email.
Gmail, yes, the
Yeah.
mail, yeah.
Go into Gmail and you
Alright.
should have a message from Miss Beckles, and all you have to do is click on join.
Yes.
Okay.
Okay. So
Okay.
why don't you go out and then go into your Gmail, look in your
Okay.
inbox, and you'll have
Yes.
a message from Carlene Beckles, and you open that mail and then click on join. There's a link there that lets you join. That's all you have to do.
Okay. I'll do that.
You want to try that?
Yes, I will try that. I'm gonna hang up and go to my Gmail
Go to your
and open it.
Gmail, open it, and you should see Carlene Beckles' email saying you can join the Zoom meeting.
Okay.
You got it?
How to join? How to join the meeting?
Yeah, well, once you get that mail, you don't have to do anything, but just click on that link she sent you.
Join.
You'll see it. Yeah,
Okay.
join the meeting.
Thank
Okay.
you.
So
Okay.
try that.
All
Let's
right.
see how that works. So just hang up,
Okay.
go into your Gmail, look for Carlene Beckles' email from you in your inbox, and you'll see she says join. All you have to do is click on that, and then you're in.
Okay.
Okay.
All right. Okay.
So try that, Yannick. All right.
All right.
Okay. Meanwhile, we'll look at the exponent rules and practice. So the product rule, whenever you're multiplying and it's the same base, notice the base are the x's, right? And the powers are the m and the n. So when you're multiplying, that's why it says product. A product result of multiplication is product. You add the exponents, right? X to the m times x to the n is x to the m plus n. And notice examples. Power of 3 on the x, power of 8, add them together, 8 and 3 is 11. When the base is a 2, the powers are 4 and 2, 4 plus 2 is 6.
That is a plus.
Yeah, whenever you're multiplying, Chastity, whenever you're multiplying exponents with the same base, you add the powers. You got it?
God.
Yeah. See, this is the power. We call it the power,
Yeah.
or we call it exponent. So 3 plus 8 is 11. Over
add them
here,
up and
the
then-
base is 2. So 4, the power plus 2 is 6. Got it? Now over here, we have variables, all variables, right? Same thing. X has a
2
2.
plus 3 plus 4, and then you just add the x,
Well,
y.
actually it's what? 2 plus 3 is 5 on the X, and 1 plus 4 is 5 on the Y. Got it?
Oh, okay.
Okay, so that's the product rule of exponents. When you
Okay, you said 2 plus 2 x.
No, see, the X has a 2 and the X has a 3, right? So
You add those
2
two.
plus 3 is 5 on the X. See, that base
Oh,
is
the
a
y
X.
doesn't have. Okay.
The Y has a 1 and a 4. So the
Where's the
Y,
oh, just because it's 1, right?
yeah,
Got it. Okay.
yeah, you don't have to put the 1
You don't
in.
see anything, then you know it's 1.
That's right. The power is 1 when you don't
Okay.
see anything. That's correct, Chastity. So 1 plus 4 gives you 5.
Got it.
So you got your product rule, right? But they have to have the same base. So X is the base, M is the power or exponent, same thing.
Okay,
X the
got it.
base, add the powers. The powers are what we call exponents. All right.
Okay.
Now that's the multiplication, the product rule. Now, if you're dividing and the bases are the same, you subtract the exponents. So you add for multiplication, you subtract for division. So base X to the M over base X to the M is the power M minus N. You got it?
Yes.
Subtraction. So if you had X to the 5th power over X to the 2nd power, 5 minus 2 is 3. So that's how you get X to the 3rd power.
Got it.
Okay. Now over here, the base is 3. The powers are 5 in the numerator and 3 in the denominator. So 5 minus 3 will give you 2. 3 to the 2nd power. Now you could have more. You got that?
Yes.
Okay. Now, if you have more than one variable, like here you have x, y, you take the x to the 2nd minus x to the 1, and you just get x to the 1 or x. Y to the 5th minus y to the 3rd, 5 minus 3 will give you y to the 2nd.
Okay, so why do we only get x
X
and
to the
a? Yeah.
Because remember, what did I just say? You subtract when it's division. You add when it's multiplication. See, times. This is multiplication.
So what is x? What is x to the power 2 minus x?
Well, this is x to the power of 2, y to the 5th, divided by, that's division now. That's why it's the quotient rule. X to the 2nd, y to the 5th, divided by x to the 1st, y to the 3rd. You follow, Chastity?
I got confused there.
Okay. Whenever you are dividing exponents with the same base, you subtract the exponents.
Okay.
So here's the base x, right? Here's the power 2 and then 1. 2 minus 1 give x to the 1. That's why I have just x. You got it?
X to the 1 because it's on. Oh,
2
I got it
minus
now.
1.
Because it's only
right?
1. Okay,
That's
got it. Yeah.
right. But when I have y to the 5th, y to the 3rd is 5 minus 3, which is y to the 2nd.
Got it now.
You got
Thank
it?
you.
Because see, I've
I
got
was
2
confused,
bases
that's
here.
why.
I got x as the base, y as the base.
Got
Okay.
it.
All right.
Okay, thank you.
Now the zero rule, the zero exponent rule. Any variable or constant or combination to the 0 power is equal to 1. So
Always.
y to this always, y to the 0 is 1. A to the 0 is 1. Q to the 0 is 1. Or if you have a constant, 6 to the 0 is 1.
Yes.
25 to the 0 is 1. Okay. Now
Okay.
here you have an expression.
Good evening, Miss Barbara.
Hello, Audrey. How you doing? I'm glad I can hear you.
I had a rough time getting on here.
I think you did. Well, we're actually doing a review, and we're starting with exponents. We're doing an algebra review of some of the things that you should know to do algebra successfully. Okay, so we're starting with the exponents. I know some of these might be familiar to you, Audrey, but it's good to review. All right. So
Okay.
this is an expression here: 7a to the 3rd, b to the minus 1, all to the 0 power. So even though this is an expression, remember I said if it's raised to the 0 power, it's equal to 1. So that whole expression raised to the 0 power is equal to 1.
Okay, you go back over that again, Miss
Okay.
Barbara.
Okay. any base raised to the 0 power, except 0, of course, is equal to 1. So you could say any variable to the 0 power is 1. That could be from A to Z. So y to the 0 is 1.
Any
B-
variable raised to the power, you say?
Raised to 0 power.
Oh, any
see the-
variable, any
Ra-
variable
Raised to the 0 power is 1.
Okay,
That's
0
called the
power.
0 exponent rule. So
Okay.
well, actually any base, the base could be a variable like here. It could be a constant like here. It could be an expression like here. See, when you have more than one term, those are, that's called an expression, right? But if you raise it to the 0 power, that expression is equal to 1 because that's the 0 exponent rule. So it doesn't matter if this was 100, 100 to the 0 power would be 1.
Mhm.
1500 to the 0 power is 1. Any constant to the 0 power is 1. Or do you have a question?
Yeah, I was going to ask you that number C that you was pointing to.
Oh, like C?
Uh-huh.
Yeah, this is an expression. So the base, you can just call this, well, although you got a base of an A and a base of the B, but it's an expression. Any expression raised to the 0 power is 1.
Oh,
Okay, so it could be a variable like A, it could be a constant like B, or it could be an expression. That's an expression raised to the 0 power is equal to 1. That's the 0 exponent rule. Audrey, you okay?
yeah.
All right.
Yes. Expression
All right.
raised to the 0.
Yes. So, because sometimes you have a calculation and you have certain variables or you have constants or you have a combination and you've got to set it. If it says the 0 power, you got to do it. You've got to change it to 1, and then you can continue with any calculations that you're doing. Okay.
Okay.
Now, here's the power rule. When you raise a power to another power, you multiply the exponents. So if you had power x, base x to the m power, and this whole thing is raised to the n power, you multiply m times n. That's called the power rule. So if you have a power to another power, you multiply the exponents. Here are some examples. X to the third raised to the second. Multiply 2 times 3 and give you x to the 6.
Okay.
All right. 3 to the second raised to the 4th power. 4 times 2 is 8. Multiply the exponents. Here again, z is a variable to the 5th power, all raised to the 2nd power. 2 times 5 is 10. That's z to the 10th power. Questions on the power rule? Okay, now there's something called an expanded power rule. And what that means is that if you have a series of variables raised to a power, each one of those variables is raised to the same power. So xy raised to the m power is x to the m times y to the actually this should be m. This is an error. Okay, that's an error. That should be, and this is a PDF, so I can't really correct it. I'll have to change it to a Word file to correct it. But that's an error. xy to the m should be x to the m and y to the m. Okay.
Okay.
If it's a division,
That's because there are 2 different letters.
well, no. This is an error on n. That should be an m. Audrey, you hear me? That's
Instead
an
of
error.
N, it should be M.
It should be m. Yes.
Oh,
Yes.
right.
This
Okay.
is a copied PDF that I got from the internet. And the corrected, I'd have to change it to, because I can't edit a PDF file. I'll have to Okay, so I'd have to change it to word and then make it M, but I'm just letting you know here that that's an error.
Okay,
It should be
okay.
X to the M times Y to the M. Just like with the division,
Mhm.
X over Y to the M is X to the M over Y to the M. You just apply the power to both the numerator and the denominator. Got it?
Yeah.
Here are some examples. 2a to the third. That's 2 to the third and what? A to the third. And 2 to the third, because exponent is just multiplying by the number of times it's in the power. So 2 to the third is 2 times 2 times 2, which is 8. That's how you get 8a to the third. Got it? Audrey, questions?
Yes.
Chastity, questions?
2a to the third.
Yeah, that's, you apply the power to both the 2 and the a. But 2 to the third is 2 times itself 3 times. 2 times 2 is 4. 4 times 2 is 8. That's how you get the 8.
Oh,
And
it's
then-
2a. It's 2a to the third.
Yeah, it's
Oh,
2a
2a.
all
Okay.
raised to the third. So you
Okay.
apply the power on the 2
And then on the a.
that's right. So 2
Mhm.
to the third means 2 times 2 times 2, which is 8. So you get 8a to the third. Got it?
Mhm.
Okay.
Okay.
6x to the third raised to the second power. So you're going to raise the 6 to the second power and the x to the third power raised to the second power. So you'd have 6 to the second power, which gives you 36. Then you have x to the third raised to the second power, multiply the powers, 2 times 3 is 6, and you get 36x to the 6. Any questions on that one? You apply this 2 to both the 6 and the x to the third. So 6 to the second, and then apply the 2 to the x to the third. So 6 to the second power is 6 times 6 is 36.
Mhm.
X to the third to the second power, a power to a power, multiplication, 2 times 3, x to the 6. Questions?
Why is it 6 to the second power, 9 parentheses
Okay.
though?
Why is
Because
it
what
not
is the
parentheses?
Yeah.
Well,
It's
you
the power
could
of
put it in
9.
parentheses, it wouldn't be a problem. But the thing is, you don't need to because you put this in parentheses, Chastity. So you're going to apply the 2
Oh.
just to the x to the third.
Oh,
But
the one that is already.
yes, but it wouldn't be an error. I mean, because it's a multiplication, whether you put a parenthesis or not. All right. I mean, you could enclose this in parentheses and say multiply it by this, but
How
you
do I know it? So the parentheses mean multiplication?
yeah, if you put
Yes.
parentheses here, that means this expression times this expression. Just like side by side, it's still multiplication. 6 to the second, and you have the expression here. That means multiply whatever 6 to the second is times whatever x to the third when you apply the power of 2.
Okay.
Because 36x to the 6 is saying 36 times x to the 6. So if you had to find the value of this and you knew the value of x, you would take whatever the value of x times itself 6 times and then multiply it by 36. That's a multiplication. Got it?
Yeah.
Okay. Now, if it were division, same thing, apply the power to both the numerator and the denominator. So x to the second over y raised to the fourth power is x to the second raised to the fourth power over y raised to the fourth power. Here again, you got a power to a power. So 4 times 2 is 8. You got x to the 8th over y to the 4th.
Wait a minute, that's x to the second raised to the fourth. That's what it is.
X to the second divided by y, all raised to the fourth power.
Oh, raise to the four. Okay. Raise to
So
the
you're
fourth.
gonna raise the x to the second to the fourth power, and then you're gonna raise the y to the
To
fourth
the
power.
fourth power.
See that, Audrey? So remember, a power to a power is a multiplication, just like
Right.
we said up here. See,
Mhm.
there's the power rule. So 4 times 2 is 8. That's x to the 8, and then divided by y to the 4th. Got it?
Mhm.
Let's look at D. 2x divided by 3y to the second whole expression raised to the third. So we apply the third power to both the 2x and the 3y to the second. So enclosed in parentheses, 2x raised to the third, 3y to the second raised to the third. So that means and then that 3 applies to both what? The 2 and the x. So we got 2 to the third, x to the third. Over here, you've got the 3 applies to the third power applies to the 3 and also applies to the y to the second, right? So this becomes two.
Wait a minute. She
Have a question?
Yeah, Miss Barbara, because these letters are pretty fine, you know, so it give you a little bit to look at them.
Okay, so
You said that it's 2x to the third, right?
over 2x over 3y
Over-
to the second, the whole thing raised to the third. Now this 3 power applies to both the 2x and the 3y to the second. You got that? That's why I have this.
So I have the 2x.
2x to the third, and then I
2x
have
to the third.
3y to the second to the third.
3y
Yeah,
to the
this
second.
raised to the third power.
Okay, raised to the third power. Okay.
Right. Now, 2x to the third means you raise the 2 to the third and you raise the x to the third. That's why you have 2 to the third, x to the third. Got it?
Wait a minute.
Right here.
You see, I have
If you have,
2 to the third.
yeah,
and
if you
x to
have
the
a
third.
product here, you raise both the 2 and the x to the third power. That's why you have 2 to the third, x to the third.
And then at the bottom
So
you
it's
have
like
what?
you separate them.
Yes, absolutely, Chastity. You apply the power to both of these, the constant 2 and the variable x. That's all
And
you're
then
doing.
and then you have 3 to the third.
Yeah,
at the
and here
bottom.
you have two things. You have a 3 and you have a y to the second. So you apply the third power that's out here to the 3 and also to the y to the second. That's why you have
So
3.
I wait to the second, you put a 3 too?
Yeah, the y to the second. Here it is here in parentheses. That's raised to the third power. Because
Okay, wait to
the
the
power
second.
applies to everything within the parentheses, the constant and the variable. This variable has a power. So you apply the 3 power to the y to the second. And that's the way it looks. 3 to the third, y to the second, raised to the third.
But the 3 to the third will be outside the parentheses?
You mean the
Little bit
3 here?
Yeah, at the bottom, yeah.
Yeah, because you have a y to the, so you have another power here. That's why
Right.
you put it in parentheses to know that you apply the third power to the y to the second. Because if you didn't, you'd have a problem, Audrey.
Right, because what I'm saying, I'm saying the 3 to the third.
Right.
Then the 3 to the third, and then in parentheses, you have the y to
Y to the
to the
second.
third.
Yeah, because you have this in parentheses because you have a power to a power.
Okay.
Okay, so you put it in parentheses to know that you're applying that third power here to what is in parentheses, which is a variable, and then a variable to a power.
And you said that is equals to 8x.
Yeah, 2 to the third is 2 times 2 times 2, which is 8, right?
Right,
So that's
right.
how you get 8x to the third.
To the third.
What's 3 to the
And then-
third power?
3 to the third is 9.
No, 3 to the second power is 9. And then
Okay,
9
three,
times
three,
3
thank you,
is 27, right?
Right,
And
27,
then a power to a power is a multiplication. So you get 3
Right.
times 2 is 6.
okay, yes, right, you got,
All
yes,
right?
yes. 3 to
Chastity,
the white power
you
is 6.
okay on this expression, Chastity?
Yeah, a little bit.
Yeah,
We need
well,
more practice.
yeah, what you do is you're applying a power to both the
Both.
numerator and
And
the
the
denominator,
denominator,
right?
yeah,
The top
Okay.
and the
and the
bottom.
bottom.
So
Mhm.
you just really breaking this up. That's the term you use before, Chastity, but that's what you're doing. You're breaking this up. So your numerator is to that power and your denominator is raised to that power, the 3. Got it?
Yeah.
And once you get this, then you saying break it up again. Now that means my 2 is raised to the 3rd power and my x is raised to the 3rd power. Okay. And then down here, my 3 is raised to the 3rd power and my y to the 2nd is raised to the 3rd power. So now you can solve it. 2 to the 3rd is 2 times 2 times 2, because that's what the exponent tells you to multiply something by that number representing the power. So 2 times 2 times 2 is 8. All right. And then that would just be 8x to the 3rd. Down here, 3 to the 3rd is 3 times 3 times 3, which is 3 times 3 is 9 times 3. That's how you got the 27. And here, power to a power, you multiply. Back up here, that's our power rule.
Is this division or multiplication?
This is division here. Okay.
And division turns into multiplication?
Well, no. Whenever you have a power to a power, you multiply the power. So it's the powers you
The
multiply.
powers is the little numbers at the top.
3 times 2 is 6. You multiplying the powers, Chastity.
Okay, but why does it say division though? What are we dividing?
Well, whenever you have a fraction, it's division. 2x over 3y to the 2nd. That's a division. That's saying 2x divided by 3y to the 2nd, all raised to the 3rd power. The expanded power rule holds whether it's an expression to the power, like here, just one expression, or whether it's a division to a power. Okay. Because really, 6x to the 3rd is a multiplication because it's saying 6 times x to the 3rd, right? That's a side-by-side multiplication. You don't see an asterisk here. You don't see a x. You don't see a dot. Side by side, 6x to the 3rd means 6 times x to the 3rd. Got it?
Yeah.
So you know how we got this 8x to the 3rd over 27y to the 6th, correct?
Yes.
Now, there's another very important one, and that's called a negative exponent. So whenever you have a negative exponent, okay, it's just remember it's 1 over the positive. So x to the minus m. Where's the talking coming from?
Oh, that was my son in the background.
Is that you, Audrey?
Yeah,
You have something on?
no, that's my son in the other room.
Oh, okay.
Yeah, he was
All right.
on my phone.
X to the minus m is 1 over the positive expression. So if you have x to the minus m, it's 1 over x to the positive m. If it were negative, then it becomes positive. So 1 over x to the minus power is x to the positive power. Okay.
Wait a minute. She says 1 over x.
Yeah. Well, first of all, if this was a minus, then it would be 1 over the variable to the positive power. Okay. If
1
this
over X.
1 over X to the plus M, there's the power minus M.
Oh, it's a
It's the
power.
reciprocal of the
Minus
base to the positive exponent. Oh,
And that would be 1 over X.
yeah, well, look at A.
Okay.
X to the minus 3 is 1 over X to the positive 3.
X.
To the minus 3 is 1 over X to the positive 3. In other words, if you have a power, if you have a base to a negative exponent, it's the reciprocal. In other words, X over 1 become 1 over X, but the exponent has a reverse sign. So it was a minus here, and now it's a plus. That's a rule. If that were a negative, 1 over X to the minus 3, it would be just X to the third.
Oh,
Okay,
okay.
that's this general format right here. If it were an expression like a fraction, X over Y to the minus N would be flip it and then put it to the positive exponent. Okay, now there's one like it right here. See this X to the second, Y to the minus 3. You put the Y on top.
X.
See
X over 2.
Yeah, you put Y over X to the second and then make your exponent positive.
It's Y. And that's the third power?
Yes, that's to the third. And now if you apply Y to the third power, that's just Y to the third. Whereas
Y.
X to the second, you apply 3, you multiply, that's the multiplication again. 3 times 2 is X to the 6. Got it?
I'm confused.
So it said, wait a minute, I get that
Okay,
one.
let's go over it again. This one,
X to the third.
there's the general format right here. X over Y to the minus N.
Oh, to the negative.
Flip it, put the Y over X and then put the positive.
Okay, well, Y over X.
That's what this one
Okay.
is. Yes,
Y
Chastity.
over X.
Okay,
Negative.
the first one, X minus M equals 1 over X. Can you explain that one, please?
Which one?
The example on top.
This one?
To your left.
This one.
Yeah, that one.
1 over X to the minus M.
Yeah, the X minus M equal 1.
X to the minus M would be 1 over X to the M. So 1 over X to the M would give you X to the M. Well, let me just, let's do that on the whiteboard. Okay, so we have 1 over X to the minus M equals X to the M. Okay, let's just go to
The one next to it, those are two different ones?
Yeah, this
That
is
one.
different. This is a power to a negative exponent. That's this one. X to the minus M, 1 over X to M. The example for that is A. You see that?
Yeah.
That's A. Because the X to the minus exponent is 1 over the base to the positive exponent.
Wait, the example that you just showing us, you say is the answer to A?
Well, X to the minus M, 1 over X to the M. The example for this one is A. You see the exponent is a negative 3, and that's 1 over X to the third power. You follow? Example for this X to the minus M, 1 over X to the positive M is A. X to the minus 3 is 1 over X to the third.
Oh.
Okay, and this one, B is the same thing. It's an example for X to the minus M because 2 is the negative exponent. So it's 1 over 4 to the positive 2, which is 1 over, and 4 times 4 is 16.
So 4 to the -2. You
Is
said it's
equal to 1 over 4 square, 4 to the second power.
Second
Right.
is equals to 1 over 16.
Yes. And A and B are examples of this x to the minus m, 1 over x to the positive m.
Oh,
Okay. Examples of that is A and B.
okay.
Okay. Example of this one is D.
Example of which one?
X over y to the minus n over y over x is equal to, flip it. The numerator is now the denominator is the numerator, to the positive n. That expression there's the example. X,
N over, no, that's X over Y.
see, x over y, and here this is x squared over y to the minus 3, which is equivalent to our minus n, right? So you're going to flip it. The y is going to be the numerator, and the x squared, the denominator, and then the exponent is plus. See, that's an example of this one.
Wait, Y over X. Wait, so
Yeah, x
the
over
example is on the
y.
left-hand side. Again, so the example is on the left-hand side and the working is on the right-hand side.
This is the general format right here. X over
X.
y to the minus n, flip it, y over x to the positive n. Example of that is D, where you have x to the second over y to the minus 3, that's the exponent. Flip it, put the y over x squared, and then put the positive exponent. You follow? So D is an example of this general.
Wait a minute, Y over X squared.
Yeah. Well, we flip it. Now the x squared over y becomes y over x squared. Notice how they flip it? X over y, y over x, negative exponent, positive exponent.
And what that would be Y, what? The D there, that would be
No,
Y.
you don't have a y square, you have an x square. Audrey, that's an x square.
Yes, we're talking about the end. At the end.
Which one are you talking about?
Well, D, it says at the end equals to Y squared. That's Y squared over X.
No,
D.
Third video, yes.
Well,
the D example. The
yes,
D example.
Are you on your email?
Yes, I'm on it.
You clicked on the.
No, not on the email. I'm on the Zoom.
Hi,
okay, you're on
Barbara.
the Zoom, so you can see the screen then.
Yes, I see this.
Wonderful. Congratulations, Yannick. That's the way you have to do it.
Hi, Barbara. I
Yes.
wanted her to start the video so you could see her.
Okay.
See, 6.
All right.
Yannick, tap the screen, and then where it says start video, I want you to press that.
Third video, yes. It didn't move.
It didn't move?
No.
Can you see Barbara again?
Yes, at the corner. I see.
You see Chastity?
Yes, I see Miss Barbara.
Okay,
see
that's fine
Chastity?
if she doesn't see you. Now you can participate in the class, okay?
That's good. She can see the screen. That's the important thing.
Okay.
Please allow Zoom access permission
Access permission to do what?
for the best meeting experience. Zoom.
No, don't touch anything else.
No, I didn't touch.
Okay, you're good with Barbara now, so you could.
Okay, that's good. You
participate in
can
the
see
class.
the screen. That's wonderful.
I see the screen, but it's only Miss Barbara at the corner. The screen is empty with all those things.
What is empty?
The screen.
You don't see negative exponents?
No, I didn't see the lesson writing. It's only a picture of Miss Barbara, and I hear her voice.
You don't see this screen that I have up.
No, the screen not with the lesson. It's only say please allow Zoom access permission.
Okay, so press yes. Press yes. Or
It's
allow.
No,
Okay.
it didn't say press and it say go ahead.
Okay, so what? It says go ahead.
Yes. It's a got it.
All right, so if you have to press got it, press got it.
Got it. Okay.
Now, do you see
What
the
do you see
screen?
now?
Now I see the screen with the math lesson, little, very small.
Okay, good. So you can use your fingers to stretch the screen if you like.
So
Did you make it larger?
No,
Do
Your
you know how to
finger.
do that?
She gotta turn her tablet lengthways and then touch open it up with her fingers.
I used to pass my
she has
hand
a
and open.
phone. She has a
Yeah, well,
phone.
you
The
could,
computer, it didn't open.
yeah, put your hand and stretch your two fingers and stretch it like you're opening them up.
It didn't open.
Okay,
Like it used to. So it's still I'm listening, and then one point on one good point says Zoom.
Yannick,
Yeah,
do you see a pointer? Do you see me moving a pointer on the screen?
do you
Not
see,
anymore. It's moved.
what do you see on the screen?
The same thing I'm reading. Allow Zoom to take picture and record video. Allow deny a dot. Ask again. Something like that.
Don't ask again. Press don't ask again.
Don't ask again.
Yeah.
Okay.
What do you see now?
I see Miss Barbara back at the corner.
And do you see the worksheet?
I see it small, like I said.
Okay, good. All right. So listen to Miss Barbara though.
You don't
Okay.
see exponents, negative exponents.
Negative exponent. I get it larger now. Yes. But Miss Barbara getting silence. It goes silence.
Silence.
Goes
Barbara,
silence. It's only you I'm listening.
let me see.
I wonder why she doesn't see the screen.
Now Miss Barbara come back.
Okay, good. I'm going to hang up the phone now, okay?
Okay. And I give her a phone back.
Mhm.
Thank you. Thank you very much.
Okay.
So I'm listening to Miss Barbara.
Yeah.
I
It's
thought she
you.
had the
It's you
screen.
coming to the street. Now Miss Barbara. Okay.
Now, Audrey, you were asking me a question?
I forget now. Since there's a lot of talking going on, I forget what it was.
Okay.
Probably it will come back.
Okay. We were looking at x over y to the minus n equal y over x. That's right. Flip it. X over y become y over x. And that's the positive n. And I said that example was D. Right? That's D. X to the second over y to the minus 3. Flip it. That becomes y over x to the second to the positive 3. Then you apply the 3 to the y. That's y to the third. Apply the 3 to the x to the second. 3 times 2, and you get x to the 6. You okay? All right. Now, the others actually apply to, let's see. Let me get here. Okay. Okay. Well, this is the minus 2. Well, y to the minus, this is really a combination. Y to the minus 4 is 1 over y to the plus 4. And you apply the minus 2 to everything, okay? This y to the minus 4 is this. 1 over y to the 4th. That's why you have the y to the 4th here. Because y to the negative 4 is 1 over y to the 4th. That's why you get minus 2x to the second over y to the 4th, and then apply your exponent minus 2. But notice this now, once you have the minus 2, this becomes, now it looks like this. Then you just flip it, put the y fourth to the fourth in your numerator, the minus 2x squared in your denominator, and then your power becomes a plus.
So that belongs to G.
Yeah,
That's the
G
answer.
is the same thing as this example. Okay. Actually, it's a combination. It's a combination of this one and this one, because y to the minus 4 is 1 over y to the fourth. That's why your y to the fourth is in the denominator here. So that's this one. But this raised to the negative power, this general format applies here, because now you flip the numerator to the denominator becomes the numerator becomes the denominator, the sign changes on the exponent. So instead of a minus 2, it's a plus 2. Got it? And then of course the power times a power, 4 times 2 is 8. Raise both the 2 and the x squared to the fourth power. So 2 times 2 is 4, and 2 times, I'm sorry, 2 to the second is minus 2 to the second, and a minus times a minus is a plus. That's why you get a 4. And then an x to the second raised to a power is 2 times 2, and you get x to the 4. That one is a little clearer when you have actually when you have the actual examples. Now there's some exponent practice, and when I send you this, then you practice the ones that I have here for simplify. I want you to practice those. You don't have to do all of them, because it's and the answers are actually here, but I want you to try them and see if you get the answers. Okay, you don't have to try all of them, just try some of them for the exponent practice. Any questions on exponents? Now some of the rules we went through you probably won't really have, but I definitely want you to know that the multiplication, you add the exponents, your division, I'll tell you the ones that you really should know. Okay, let's go back here.
I was just confused a little bit on the last one, the G.
Okay, let's go to the one. Which one were you confused on?
The last one, the
Negative
G, right?
exponents.
Yeah.
The G, this one?
Yes.
Okay. Now, whenever you're raising, well, this is minus, well, let's do it step by step. The y to the minus 4 is 1 over y to the fourth. That's why this y to the fourth is in the denominator here. That follows this rule, Chastity, you see? Y to the minus 4 is 1 over y to the fourth. That's why the y to the fourth is in the denominator. So are you clear right there?
Yes.
Okay, now the minus 2 is applied to now minus 2x to the second over y to the fourth. But when you have a negative exponent, you flip the fraction and put the numerator for the denominator for the numerator. So that means your y to the fourth is the denominator, that would be the numerator here. The minus 2x squared, which is the numerator, becomes the denominator. And the other thing you do is change your exponent to a plus.
Okay, so y at the bottom is y4, but what happens to the minus 4?
Oh, that's what I'm saying. What is y to the minus 4? Let's go over here. See, x to the minus 3 is 1 over x to the third, right? Y to the minus 4 is 1 over x to the fourth. That's why the 1 over y to the fourth. That's why the y to the fourth is here, because the y to the minus 4 is 1 over y to the fourth. That's why your y4 is here in the denominator. You got it? this y to the minus 4 is equal to 1 over y to the plus 4. So that's why you have the y4 here, y to the 4th. Chastity, is that clear?
So you flip it like you say.
No,
So
no,
y minus
no.
4.
Well, no. You see this rule here? The power
Yeah.
to a negative exponent becomes 1 over the base to a negative exponent becomes 1 over the base to the positive exponent. That's why the y to the minus 4 became 1 over y to the 4th. That's why the y to the 4th is here in the denominator, because of the rule of the negative. Well, right here is the general rule. Base to a negative exponent is equal to 1 over base to the positive exponent. So y to the minus 4th is 1 over y to the plus 4. That's why this y4 is here. That's the 1, you don't see it here, but 1 over y to the 4th. You follow,
Oh,
Chastity?
okay.
You got it?
Yes.
That's
I'm
why the
following
y
the
to the
rule.
plus 4th is here. Now you just keep going. You just say
Yeah.
minus 2x squared over y to the 4th, apply your minus 2. What do you do when you have a negative exponent? You flip the fraction, so the y to the 4th is now in the numerator, and the minus 2x squared is in the denominator, and your minus 2 exponent becomes a plus 2 exponent. You got it?
Oh, you don't put the plus?
Well, you don't have, you generally with plus,
don't
you
have
don't
to,
put
eh?
it. Yeah. If you
Okay.
don't see a sign, it's plus. If it's
Okay,
negative, you
gotcha.
have to put a negative. That's the rules of the math, right? If
Okay.
it's negative, you've got to put a negative sign on it. If it's not a negative, you can leave it blank.
Okay,
Okay?
got it.
It's just like the coefficient in front of a variable. If you don't put anything there, it's a 1. Like this is 1y to the 8th. You don't see the 1, but that's what it is. But it's understood to be a 1 when you don't put a coefficient. Whereas if you need a coefficient, like here, the coefficient is 4, you have to put it there, right? 4x to the 4th. So Chastity, do you know how I went from here to here?
Yeah, you multiply
What did I
2
do?
times, multiply the top 4 times 2,
Right. And what
and
happened
it
in the
gave me a,
bottom?
and then you multiply.
Minus 2 times a minus 2. So what you do is you raise the minus 2 to the second power, and you raise the x to the second power to a power. So a minus 2 times a minus 2, remember multiplication, like signs give you plus. So a minus 2 times a minus 2 gives you a plus 4, right? And then you have x to the second to a power of 2, and you multiply the powers. 2 times 2 is 4. That's how you get 4x to the 4th.
Okay.
Got it?
Yeah.
Audrey, you okay?
Yes, I'm all right.
All right. So I said you have some exponent practice. I'll send you this file, and I want you to practice some of these, and the answers are there. You don't have to do them all, but I just want to emphasize what I really need you to know. Okay. So some of these you probably won't have. You definitely should know your product rule. You should know that when you're multiplying exponents, you add the powers. Definitely know that. Know that if you're dividing, you subtract the powers. That's important. Know that any power, any base raised to a 0 power is 1. That's very important. Okay. So 1, 2, 3. Okay. 1, 2, 3, 4, and 5. You should definitely know those. Okay. The other ones, You don't really have to know those. Well, of course, the negative exponent of going to a positive, that you should know. This one, not so much, but if you have one variable or one constant and it's raised to a negative exponent, it's 1 over the base to the positive exponent. Okay? So those you should definitely know. Okay? And in terms of expanded power rules, just the multiplication, that if you have a product, you're raising it to a power, then each entity within the parentheses.
The product you say
must
add
be
to Miss Barbara,
yes.
you says the product you add.
Yeah. The thing is, okay, let's back up here. That's why it's called a product, because you what? You multiplying. When you
Right.
multiply exponents, same base, add the powers. When you
You multiply the same.
dividing,
Wait, you multiply, you're going too fast. You say you multiply the
same
base
base.
or the same base.
Yeah, you can't do this unless it's the same base.
Yeah, you
And
multiply the same base.
Yeah, when you multiplying and the bases are the same, you add the exponents. So I have x to the m times x to the n. See, this won't work if it's x to the m times x times y to the n. It only works if it's the same base. Notice x, same base, 2, 2, same base, x,
Where is
y.
that her saying that? Which number is that?
What? I'm at the product rule.
Oh, okay, I know, see it. Okay.
Yeah, you see the
Exponent
product
rules
rule?
and practice. Exponent rules and practice.
Yes, I'm at the product
Okay.
rule. If you multiply and your bases are the same, you add the exponents. It's called the
Okay.
product rule because what do you get when you multiply? You get a product. Result of multiplication is called product. Result of a division is called a quotient.
Mhm.
So if you're dividing, you subtract the exponents. Those are very important.
If you're dividing, you subtract the
You
exponent.
subtract the exponents. There again, they have to be the same base. See here, x of the base, 3 of the base, x, y, the base. Okay? So if they're the same base, you subtract the exponents. And then the zero exponent rule, any variable or number or combination raised to the 0 power is 1. That's a very important one. Okay. Then of course, a power to a power, you multiply the exponent. That one's important. Any questions on exponents? Now I'll go back to what we were doing in our review. Okay. Can you see this? College Prep Math Algebra Review? Yes.
Mm-hmm.
Exponents, we went through the rules. Now we're looking at ratio proportion. Now, ratio proportion is a powerful tool for problem solving. And the ratio is you comparing two quantities, and you can write it as A to B. You can express it as A colon B, or you can write it as a fraction. In other words, let's see. 1 colon 2. You can write it like that, or you could say what? 1 over 2. Or you could say ratio of 1 to 2. All those represent a ratio. You comparing quantities. Now, most of the times you're using like a variable. Okay. So if we said E D, that's the ratio of E to D. Or we could say E divided by D. So ratio is just a fraction. You're comparing quantities, all right? But now when you set two ratios equal, that's called a proportion. So know the difference. The ratio is just comparing two quantities. When you set two ratios equal, that's a proportion. And that's the power of ratio proportion. Because if you've got three things, you can solve for the fourth one. Example, Nicholas drinks 8 ounces of milk for every 5 cookies he eats. If he eats 20 cookies, how many ounces of milk does he drink? See, now you know 8 ounces of milk for every 5. That's the ratio, 8 to 5, right? Now, you're trying to find if it's 8 to 5, what is my ratio of milk to cookies when it's 20 cookies? So it's very important that you put them in order. And that's why I put, and also that they have the same units. So I did this so you'll see here, 8 ounces, that's the quantity of milk, 5 cookies, right? 8 ounces of milk for every 5 cookies. That's the ratio. I can set it equal to how many ounces of milk if I had 20 cookies, right? Now, actually, you could solve this without a ratio. And what would you get, Audrey? You could solve it without a ratio. What would you get? I mean, this is mental math. You could solve it without a ratio. You know what it would be, Chastity?
40?
No.
No.
Well, Chastity, look. 5. What's the relationship between 5 and 20? What do you multiply, Chastity, by 5 to get 20? Chastity, Chastity, you multiply 4, right? So if you multiply 5 times 4 to get 20, 8 times 4 is what?
32.
Chastity,
Oh,
you're on mute.
32.
32. Okay, so you know the answer here because you know the relationship between 5 and 4. So 5 times 4 is 20. 8 times 4 will give me 32. See, this is one where you could really do it not the math, because you say, well, 5 is like what, 1/4 of 20, or 20 is 5 times 4 is 20. So my ounces of milk is going to be 4 times 8 or 32. Or you could set it up as a ratio because they're not always so simple to figure out. 8 ounces of milk, 5 cookies. How many ounces of milk? And I just call that N for 20 cookies. Cross multiply. 5 times N is 5N. 8 times 20 is 160. And here you can solve for N. Divide both sides by 5 and see you have 32. 160 divided by 5 is 32. So this ratio proportion is a really powerful tool. Chastity, I sent you the ratio proportion, right? I sent you
Today?
No, I emailed you something on ratio. Well, yes, because Maureen had asked for some extra algebra problems, and one of them was using a ratio and proportion, and it was one she couldn't figure out, but I sent her the explanation of how to set that one up. Did you get it, Chastity? That ratio?
I'm not sure.
Open the
I will
door
have
for
to check.
whoever.
Well, it was additional algebra problems that I had sent to, well, actually, I had sent it to Maureen, and
I
I
don't
think it
think
was,
I have it because I've been going through it.
and yes, Maureen wanted something on ratio and proportion, and I sent something on ratio and proportion. That's probably what it's under, with some samples worked out. Okay. Let me know if you didn't get it. Check and see if you have the ratio proportion. Audrey, do you need it?
Checking now.
Huh?
Do you need the ratio proportion
You
problem?
can send it. It
Okay.
won't hurt.
All right, I'll send that to. Send to Audrey.
What are you talking about?
I am Friday. I got it.
Did you get
Friday,
it?
right?
You got it, right?
Yeah.
Yeah, okay.
Yes.
Yeah, and it was one
What,
that,
the hoodie?
that I had suggested that Maureen use ratio proportion, and she said she was confused. She didn't know what she had to do. All right.
Yeah,
So I actually worked it out and set the example.
that is something. He didn't use
But
it.
that's a powerful way of problem solving. And actually, one of your questions on your quiz involves ratio proportion, and I think you could probably set it up. Okay. Now let's go to the next topic, which is factoring. Audrey, what's a quadratic equation?
Quadratic equation?
Yeah.
Oh boy.
And how do you know it's quadratic?
A plus B,
Well, quadratic equations, you have a variable raised to the second power. That's how you know it. Versus linear equations don't have any powers other than one. Right?
Yeah, sure.
So you know the difference? Chastity, have you heard of a linear equation?
Linear equation, I hear about that.
Not really, no.
Linear.
Brand.
Just put here. Linear equation.
What part she is though?
Okay. No powers. And one of your most familiar one is y equal mx plus b, where m is the slope and b is the y-intercept.
Yeah, I'll come back in the sheet and get in that.
Yeah, that's one a very important linear equation. M is the slope.
I'm not seeing you.
B is the
That's where you are.
You're not. I'm on the other side. You may have to scroll to your right. Do you see it? Factoring of quadratic equations.
See that?
Chastity, you see it, right?
Yes.
Factoring of quadratic equations. Audrey, you may have to scroll to your right.
Okay, let me see.
I'm on the right side of my screen. See it, Audrey? Factoring of quadratic equations.
Let me see.
Yes. You see it? No, Audrey? Audrey, you see it? Audrey, you're on mute. Audrey. Okay. Linear equations, as I was saying, they don't have powers.
Everything was for me, Curtis.
Quadratic.
Anything was for you?
Miss Beckles, you should be on mute. Miss Beckles, you should be on mute. Okay. This is a standard quadratic equation. A, that's a coefficient of x squared plus b, coefficient of x, plus c equals 0. That's a quadratic equation. Now, when you plot these, the linear equation has a straight line. Quadratics have a u, upside down u, or a regular u. Let me go to the new share. Okay, now let's just draw a line. Let's draw like a coordinate. Now, linear equations have straight lines, like, okay, that's linear, right? Quadratics have, it look like this, or they could be upside down.
Who did the mail belong to?
If it belongs to correct.
Miss Beckles, you should be on mute. Miss Beckles, on mute. Miss Beckles, go to mute. Miss Beckles. She must. Miss Beckles, go to mute.
How come she can't hear you?
I think she can't hear me, but she's talking. Miss Beckles,
Where,
go to mute. Okay, so the straight line, and it could be increasing or it could be decreasing. Downward is decreasing, this way is increasing. But the quadratics, if you ever had to recognize them on a graph, they have, you can call it like an upside down U or a regular U. So that's how you know the difference. Linear equations, if you plot them, you get straight lines. Whereas quadratics, you do not get straight lines, okay? So back to review. Now, this is a quadratic. Now, the way you know that, because it always has a square on one of the variables, always, never more than a square. That's the highest power it will have, all right? So here's an example of a quadratic. Now, notice I put the general, ax squared plus bx plus c. Now, a is the coefficient. What's the coefficient, Chastity? What's the coefficient?
Audrey, what happened? You left.
Is the letter
No,
in the beginning?
what the coefficient
All right.
is,
So,
that's the number in front of the variable.
Okay.
That's the
that's a letter.
coefficient. No,
all right. So you have to
what
go
do you
to
see? No, that's A right here. Oh,
Okay.
unless I'm not sharing.
What you saying you're saying is a number?
Okay, right here. Do you see ax squared plus bx plus c?
Yes.
Okay, the coefficient of the x squared is A. The coefficient of x is B. That's the number. If we put numbers here, it would be the number in front of the variable.
Okay. I
So-
thought it will always be like numbers, not letters. But now I see.
No, this is the general format of a quadratic.
Okay.
So once you write the general format, then you say, well, let me put numbers here. Now my A is a 4, my B is a minus 12, my C is a minus 16. Got it?
Yeah.
Yeah.
But a lot of times you're given a general format and you use that to determine if an equation is linear or quadratic. But if it's quadratic, it will have a variable raised to the second power. No higher power than that, but a second. Whereas linear, its highest power will be 1, like here,
That's
x
fine.
to the 1.
Then you have
Okay.
to put eight,
Now,
right?
This
here's
linear equation is no powers.
no powers, right? No powers. You plot them, you get straight lines. Quadratic equations, you plot them, you don't get straight lines. You get something that looks like a U upside down or a U
So you remember
regular.
the thing about Wi-Fi and something you were telling me?
Excuse me.
Miss Beckles,
Yes.
go to mute because you're talking to somebody.
Oh, I'm so sorry. I was talking to Audrey. She got dropped. Sorry.
Oh, okay. No, you were talking before then, but I don't think you heard me. You were talking to somebody, I think, at the house. Okay. 4x squared minus 12x minus 16. Now, notice when you see numbers like this, you think right away, I can make this simpler, okay? Because I see each one of these numbers can be divided by what, Chastity? Each one of these coefficients and constants. What do they have in common? What factors do they have in common?
Multiplication.
No, factors. No, let me put it another way. What number can be divided into each one of these numbers? The 4, the minus 12, the minus 16.
Mm,
Or just think about it. What are some factors of 4?
2, 4,
2, 2, and 4. What are some factors of 12?
3,
3 and what?
3, 6, 9, 12.
No, give me 2 numbers I can multiply and get 12.
Mm, 1,
That's not a 1. Okay. Factors of 4. Okay. And you said 4 times 1, that's 1. Or you could say 2 times 2, right? Okay.
yeah.
Let's go factors of 12. These are numbers you can multiply and get back that number. So give me some factors of 12.
You said 1 is no?
No, I don't want you to use 12 times 1.
Okay.
It's okay to use it here because we're going to find that 4 is going to be a common factor for all of them. Okay, but factors of 12, but don't give me a 1. What are 2 numbers you can multiply and get 12?
4 times 3.
Right, excellent. 4 times 3, what else?
Um,
Give me another one, one more.
I don't know. I mean, 3 times 4.
That's the same thing.
Let me see.
What's half of 12?
6.
What times 6 give
times
12?
4.
That's 24.
6 times 3.
6, that's 18. What number times 6 gives 12?
2.
That's it. Okay, now let's go to 16. Factors of 16. What are some factors of 16? 2 numbers I can multiply and get 16.
Hold on. 4 times 4.
Right, that's the one I wanted to hear. Okay, that's, and also you could say what, 8 times 2, that's also a factor. But now what I want you to find is what factor is in common for all 3 of these numbers, 4, 12, and 16. What do you see as a common factor? It appears in factors for 4, 12, and 16. What are they?
2, 6, and 8. No, 4.
4, because no, I said common. So in other words, 4 is a factor of 4, 4 is a factor of 12, and 4 is a factor of 16. So that means then I can take that number, I mean that quadratic, this, and divide each one of my numbers by my coefficients and my constants by 4, right? So let's just copy that. Now divide each one of these by 4, okay? Do the same for the minus 12x, okay? And for the 16. Now, so I'll put the 4 underneath here. Okay, that's 4. I'll put, it's not, no underline there, okay. And then I'll put the 4 underneath the 12, the minus 12. So that's a 4 and 4 here. See, we're trying to simplify it so it will look like this, that ax squared plus bx plus c, where a is a 1, okay? So let's just make that. Okay, so what's 4x squared divided by 4, Chastity?
8.
4x x squared divided by 4? What's 4 divided by 4?
1.
1. So that would just be 1. Let's just write this. Okay. So 4x squared divided by 4. And it would just be 1x squared, right? So let me just put a 1 here. We don't have to put it, but I'll put 1. Now, what's 12 minus 12 divided by 4?
12 minus 12.
No, minus 12 divided by 4. This is the division. What's 12
Okay.
divided by 4?
3.
3, that's right. Okay, so that would be minus 3x, right? Now, what's 16 divided by 4?
4.
4, that's it. Okay, so now we have our equation in a simplified form, right? Now, we don't have to put the 1x. We could just leave it as just x, right? So let's just copy it here. Okay, so let's just, the 1 generally we don't put it. So x squared minus 3x minus 4 is 0. Now, when we want to factor this, let's just put a skeleton of our factors. When I say factors, I mean what expressions multiply to give me back the quadratic. All right, and since you have x squared, you'll always have an x, right? You'll have an x. Okay, so we know we have an x in both of our factors. Now, what you want to ask yourself, what numbers can you multiply and give a negative 4 and then add them to get a negative 3? Yannick, do you know? What two numbers multiply? In other words, the product is equal to what we call this C, and our C here is a negative 4. And when you add the sum, you get the B, which is the 3. So Chastity, can you think of two numbers? You multiply, you get a negative 4, and you add them and get a negative 3.
No, I don't know how to do it.
Okay, let's take the negative 4. Give me two numbers you multiply to get a negative 4.
2 times 2.
That's 8. Two numbers I can multiply and get a negative 4.
4 times 1.
Yes, 4 times 1. Okay, so we put 4 times 1. Now, that gives me a plus 4, right? How would I get a negative 4? What would I have to change the sign on something? What would the signs be to get a negative 4? Remember, I said to get a negative 4. So to get a negative, one of my signs has to be plus and one negative. Which one do you think should be negative?
Minus 1.
What's a minus 1 and a plus 4?
Minus 1 and a plus 4 is minus 4. No.
A minus 1 plus 4. What is that equal to? Unlike signs, you subtract, and your sign is that of the number with the greater absolute value. So what's a minus 1 and a plus 4?
Plus 5.
No. When the signs are unlike, you subtract.
1 minus 4, so it's 3
It would be a 3. It would be plus or minus.
plus.
That's it. Very good. It'd be a plus because you use the number that has the biggest value sign, right? But that plus 3 is not the minus 3, because remember I say you multiply it and get the not minus 4, and you add it and get a negative 3. So it can't be a minus 1 and a plus 4. So what must it be? What must the two numbers be that I multiply to get a negative 4, and then I add to get a negative 3?
Negative 2.
No, you stay with your 4 and your 1. Let me just put it here. It's going to be the 4 and the 1, like you said, but we've got to get our right sign. So let me just put the 1 here. Okay. It's going to be a 4 and a 1, but what must be the sign of the 4 and what must be the sign of the 1?
There's positive 4 plus negative 1.
Well, that's what you put here. Remember, we got a plus 3, and that's a negative 3. So it can't be that. We just found that's going to make our 3 plus. So what
You have positive 1
right. Okay. And what about the 4?
minus 4.
That's it.
Negative 4.
That's it. You got it. That's it. Because see, a minus 4 product of minus 4 and a 1 gives you a negative 4, right? But if you add a negative 4 and a 1, you get a negative 3. So that's going to be the answer. This would be, and we said equal to 0. So the factors must be equal to 0. That means now, if the whole thing is equal to 0, then each of the factors equal to 0. So x minus 4 is 0, x plus 1 is 0.
Okay.
So the thing is, when you're given a quadratic and the factor is a 1, like we had this as 1, right? You can just go ahead and put an x and an x. Now you have to figure out, what must my numbers be? And my numbers must multiply to give me the constant. The same two numbers must add to give me my b. That's my bx. See, bx. Questions? You have to practice with some of these because we're going to keep them on the simple side. I don't want to give you some that will cause you a lot of work to figure out. But you got to know your signs, right? You've got to know plus times minus is minus. Plus times plus is plus. Plus added to minus is a subtraction. And all you have to remember is that if you have more negative than plus, your net is going to be negative. So if you have, let me just take this. If you had, Chastity, suppose you had a minus 8 plus 5. What would that be equal to, Chastity?
That will be,
First of all, you subtract, and then your sign is the number with the bigger absolute value. That's the number where you disregard the sign, and it's the bigger of the number. So first subtract. So what do you get when you subtract?
3.
3, right? Now what would be the sign?
Positive 3.
The number with the greater value, absolute value. And that's the 8, right? Or the best way to look at it, if I've got more negative than positive, my result will be negative, right? You have 8 negatives and 5 positives. your result will be negative because you got more negative than positive. You got it? So you
Yes.
subtract 5 from 8, you get a 3. The sign is negative, and you say the negative because my greater absolute value is 8, which it is. But another way of looking at it is I've got more negative than positive, so my answer will be negative. Is it clear, Chastity?
Okay.
All right, let's take another one. I'll make sure you understand. Okay, suppose I had plus 15 minus 20. What would that be? What would be my answer? Now, I didn't have to put the plus 15. I could have just left it as 15 because if you don't put it, it's plus, right? So what's 15 minus 20, Chastity?
15 minus 20 is 5.
Plus or minus?
That's
5 is correct, but what's the sign?
it's a minus.
That's it, minus. Yes, because you subtracted 15 from 20, you got 5. Your bigger number is the 20 that has a negative, that's your sign. Or like I say, you got more negative than plus, so your answer has to be negative.
Oh, that's easier.
Is it making sense? First of all, your sign rules. You add like signs, you get the same sign. In other words, minus 9 and a minus 7. What would that be equal to, Chastity? Same signs you add.
That would be 16.
Plus or minus? Same sign.
So it's minus 16.
That's it, minus 16. Whereas if you had a plus 9 plus 7, it would be a plus 16.
Okay.
Okay, same sign you add with negative, same sign you add with plus. Okay, unlike signs, you subtract. That's your key. You subtract if they are unlike. Okay, and your sign of your number is the one that has the greater absolute value. Okay.
All right.
Okay, suppose I had 6 plus 18. What would that be equal to, Chastity?
That would be, hold on, let me think.
Adding 6 and 18.
That's 24.
That's it, 24.
Plus 24,
Plus,
right?
yeah, that's right. Plus, 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 plus gives you plus. Okay. Now
Minus give me minus.
That's right. Now let's go to unlike. 33 minus 17. What's that equal to? Plus 33 minus 17. Unlike, you subtract, use the sign of the number that you have the most of. So what's 33 minus 17?
16.
That's 16. And it's plus because what? I have a plus 33. That's my bigger number. Or if you look at it, I have more plus than I do minus. So my sign will be a plus. And you can put a plus or you can leave it out. That's your default.
Okay.
Got it?
Yes.
Okay. So we'll stop here. I have some more. I'll send you this because I want you to look at converting words to math, and work problems. And I have some worked out here, and we'll probably do some more. Okay. We'll postpone our algebra tests because I want to go through some more of these, especially with the converting words to math. I want to make sure you're really solid on your signs. So we'll look at for next Monday our algebra test. All right.
Oh, thank you so much.
Okay. So next Monday we'll do our algebra test. I will send you the session we went over, and we'll do some more practice of some of the key things that I want to review with you. Okay. And then I want you to feel
Okay.
more comfortable that when you get the quiz, you'll be able to answer the questions. Okay.
Okay. Thank you, Miss Barbara.
All right. So this, I will email to you the session we went over today. Your homework is just really to understand the things on that we went over and the ones we didn't go over, and I'll go over those next time. Any questions on anything?
No.
Okay, so algebra quiz next Monday. All right, what date is that? Next Monday.
Next Monday is the
April. Let's see, look at my calendar because I want to put it on here. Okay.
I think it's the 5th, if I'm not mistaken.
Let's see.
No way that I get
0419. Let me just make sure. Okay, my calendar. Okay, April. Yes, April 5th. Okay, so I will put it on here. Put it on here. Okay, algebra quiz. April 5th. Now, we will do the quiz after we finish up this review that I have here. That's why I want you to look it over, for your homework, because we're going to do the quiz during the class. All right. You'll have 10 questions, 3 extra credit questions, and you'll do them during the class, and then you can text me or email me the answers. Any questions on anything?
I can't hear me.
Okay, so thank you for sharing. See you at the next session. Enjoy the rest of your evening. Okay.
To you, Barbara.
All right.